Hi, this video is on moving straight ahead, problem 1.2, and we're talking about walking rates and linear relationships. And our LAQ is, how does the constant rate of change show up in the table, graph, and equation? So we're going to be making tables, graphs, and equations, and we'll be observing the constant rate of change. So in this story, there are 3 students that we're going to look at from Ms. Chang's class from problem 1.1. They are going to be creating a walkathon to raise money for charity for a children's hospital. And so each student has calculated their walking rate in an experiment, like we talked about from 1.1. And so Alana finds out that she walks 1 meter per second, which isn't very fast at all. But her classmate Gilberto walks twice as fast. He walks 2 meters per second. And then Leanne must have really long legs because she's walking even faster than them, and she walks 2.5 meters per second. So what we're going to do is we're going to use those walking rates, and you have this table in your paper, and what I'd like you to do is to please fill in a table for each student. So if Alana walks 1 meter per second, then after 0 seconds, she essentially hasn't started yet, so that would be 0 meters. Then after 1 second, she would have walked 1 meter. So for every second, she walks 1 meter per second. So for 2 meters, it would be 2. So you're going to continue to fill that in for her. And for Gilberto, he's a little different. See, he also starts at 0, because at 0 seconds, he hasn't walked yet. After 1 second, he's going to be 2 meters in. So for every second, he walks 2 meters. So that means after 2 seconds, it will be 4. And if you would so complete this table then for Alana, Gilberto, and also Leanne, and then we'll move on from there. So I'm going to fill in this table, and as I do so, I want you to notice that I'm using 3 different colors for the students. So Alana's color will be green, and Gilberto's color is blue, and Leanne's is purple, and I'll be consistent with that throughout the rest of this presentation. So it would be a good idea if you to use a highlighter and choose 3 colors, or choose 2 colors and have 1 kid that doesn't have a color, so that would be fine too. And that way, as you go through, you can color code it. So Alana, since she walks 1 meter per second, I notice that the number of seconds and the number of meters are actually the same number. They're a 1-to-1 relationship. 1 meter for 1 second. Gilberto's numbers, you notice that he's doubling the seconds for every meter. So every meter is twice as many as the seconds. And then Leanne, she walks the fastest. At 0 seconds, she's walked 0 meters, and then she's walking 2.5 meters for every second. And so her table increases this way. So as we look at that, we're going to use these table values, and if you have them incorrect, you should fix them. You can pause the video and fix your table. We're going to use this table to find the constant rate of change for each of the students. Even though they're giving us the walking rate, we're going to write it as a constant rate of change. So, and then notice on my paper, I have the 3 different colors of the students again. So what you're going to do is you're going to fill in the pattern as the time increases by, and for each table, the time is increasing by 1 second. So as the time increases by 1 second, the distance for Alana, her distance does what? It increases. It's getting bigger, so it increases. Increases by, that's hard to write the word increases. I'm trying increase. There. Increases by, what does it increase by? 1, 2, 3, what's the pattern? It's going up by 1. So by 1 meter. So as her time increases by 1 second, her distance increases by 1 meter. So if you would please fill in the blank for the other 2 students, what you're writing is the constant rate of change. So now that we observe the pattern in the table, now we're going to make a graph. We're going to make a graph for each of the students. On the graph, it says which is the independent variable and which is the dependent variable. Well, since the distance they walk depends on how long they're walking for, the time is the independent variable. The time in seconds is independent. And the dependent variable is the distance, because the distance depends on the time. Right? It depends how far you get, depends on how long you're walking for. This is bad, I'm sorry. There you go, distance. So I already have distance on this graph for you, the distance in meters, and notice I have it going up by 2. And the reason why I'm using a scale of 2 is so that we can get all of Leanne's data in our graph, because Leanne walks the fastest of everybody, and so she's going to get all the way up. If we put all the information from our table in our graph, then we have to get all the way up to 25 meters. So I needed to go up by 2. On the x-axis, we're going to put time, so I'm going to label time. And normally you would put your labels on first, and then you would write the scale second, but I already had part of that done for you. So now I'm going to put seconds, time in seconds here. And think about our table. Our table is going up by 1 second. So we want to show each of those values. We want them to be easy to read points, and it would fit in our graph. So I'm going to go up by, here would be 0 seconds. And then this will be 1, skip a line, 2 seconds, 3, and then write 4. So what I want you to notice is, as a shortcut for making a graph, I don't have to write every number. This line here represents 5 seconds. I'm not going to write it. I'm going to skip a line and write 6. This represents 7. I'm going to write 8. If I write every other number, it takes me half the time. Now, for some people, it's very hard for them to read a graph when you skip lines, so maybe you're at a point where you still want to write every number. But over time, I hope that you would see that it's a lot faster to just write every other number. So then what you're going to do is, once you have your scale set up, you're going to start plotting points. Now I'm going to plot these points, and when I do right now, they'll be in red because of the PowerPoint I'm using. But when you see the next slide, you're going to see that Alana's points come up in green. So I'll start with Alana's points. So Alana walks 0 meters in 0 seconds. After 1 second, she's walked 1 meter. 1, if I go up here, that's 2 meters. So 1 meter would be halfway between them. Okay, so because of that, I'm not going to put a dot there. I'm not going to put a point there. I'm going to skip and go to 2 because I'm only going to put in the easy to read points. So 2 seconds would be 2 meters, and I'm going to put a point here. And you're going to see what happens here in a second. 3 seconds would be 3 meters. But I'm not going to put a point there because that would be, it wouldn't be on the line. I'm going to make easy to read points only. So 4 seconds is 4 meters. 6 seconds is 6 meters. See, I skipped 5. 8 seconds is 8 meters. And 10 seconds was 10 meters. And what if you notice that all of her points are lined up, and they would make a straight line if you connected them. And if you think about it, in order for this to work, she's not walking for a second and then jumping to the next second. She's walking over time. So there's a half a second here, 2.5 seconds, 4 3/4 of a second. Like, she's walking, continuously walking. So really, in order to show all the points, the best thing, and this is going to be really bad, I'm going to do my best here, but the best thing to do would be to connect all these with a straight line. Pretend it's straight with a straight line. And if you were on your paper, you should use something straight. And I'm going to use a straight line, boom, to connect her points, because Alana's continuously walking. And so what I did was I only plotted the easy to read points, and then I'm going to connect them with a line. And that way I get a straight line. I'm not going to estimate in between. It's also going to save me time because I'm not going to have to put every single dot in. And so when you get to Gilberto, his points will be very easy to make. But when you get to Leanne's graph, hers, you also need to be thinking about what's the easy to read points. And then see, does her graph also make a line? Do we have 3 lines here? All right, so go ahead and finish that graph and see if you have 3 lines. And color code them with the same colors you used in the table. And then you can write your answers here. So now I'm going to show you the graph that I made with the PowerPoint, and the colors will match. And so here are Alana's points, and notice how they make a straight line. Here are Gilberto's points, and notice how they line up in a straight line. And then finally Leanne, the faster walker, and her points also line up in a straight line. So all 3 of these have graphs make a straight line, and that's because they have a constant rate of change. So if the line is straight, there is a constant rate, and if there's a constant rate, the line is straight. But you may notice that each line is not at the same angle. So if we remember, so Alana's walking, and here she is. That's not the actual Alana, that's just a clip art. And what I want you to watch as Gilberto's line, when he walks up his line, notice that he walks faster. And Leanne is the fastest of all. So how do the graphs compare to one another? So remembering that Alana's walking rate was 1 meter per second, and Gilberto's walking rate was 2 meters per second, and Leanne's 2.5 meters per second. How do they compare? You might want to say that Leanne's graph is higher than Alana's graph, or it's I think sometimes we have a hard time putting it into words. We have a math word for that. The word is steeper. So Alana's line is steeper than the other 2 lines. It's like it's at a higher angle in the graph. So it's steeper, and that's because she's walking the fastest. And Alana's line is the least steep because she's walking the slowest. So if our class walking rate, our average, or the one that we use for 1.1, was 1.66 meters per second, where would that fall on this graph? Would it fall below Alana's line? Would it be above Leanne's line? Would it be between Gilberto and Leanne? Or between Alana and Gilberto? So if our walking rate is 1.66 meters per second, think about that. Where would that line show up? Well, since 1.66 is between these 2 rates, it would be between the 2 of them. So it'll be and I'm not going to be exact, but it's going to be somewhere in here, right? And it would actually be straight, not like my line. But that's where our walking rate would be, between Alana and Gilberto. So I've already started filling this in for you to show you how we're going to be looking at the equation. So for the equation, we're looking, what are we doing to the time to get the distance? And Alana's the harder one because it's so easy. So to find the total distance that Alana travels, you could multiply the time by 1, and you would get the distance. So to find her distance, you multiply it by 1 to get the time. And then you can look in her table and see if I'm right about that. Notice that 1 is her walking rate, 1 meter per second, and you multiply by that 1 to get the distance. So now what I want you to find is, what do you multiply Gilberto's time by to get his distance? And then you can write an equation. And what do you multiply Leanne's time by to get her distance? And then you can answer this final question. How can you know that the graph will be a straight line? By looking at the patterns in the table. So now we've looked at constant rate of change in the table, we looked at the pattern, we looked at constant rate of change in the graph, and how the steeper the line, the faster the rate. And now finally we've looked at the equations, and you're going to see where the constant rate of change shows up in the equation. You're going to see that number for each one. All right, thanks for watching.